We will start with forces and field unit, which is the second unit on Physics 30. And this unit has 3 blocks of videos. The first one is electrostatic, the second one is electric field, and the third one is magnetism. Now, electrostatic has been always an intrigue to scientists to study and to see how and why this is happening. And if you want to read about and talk about the history, then I can refer you to some documents in class. However, now we will talk about the modern theory of the electrostatic. And the modern theory of the electrostatic is stating that the first law that we will talk about is that like charges repel, and unlike charges attract. So this is bringing us into how many type of charges do we have? We have 2 type of charges. Positive charges and negative charges. First of all, we have to clarify how those charges are created. So now we know that atom is at the center is there are protons and neutrons, and the electrons are going around the nucleus in 2 different orbits. So when we have the same number of protons as electrons, then the object is considered to be neutral. But when the number of protons is different from the number of neutrons, of electrons, then we have an object that is charged, either positively or negatively charged. If the number of protons is greater than the number of electrons, then so we have more positive than negative charges, then the object is positively charged. And if number of protons is less than a number of electrons, then we have an object that is negatively charged. However, we know very well now from chemistry and other sciences that we have taken that if the number of protons is changing, then that doesn't happen. What do we have is we have a different element if the number of protons is changing. So what are flexible that move from one object to the other is the number of electrons. So what is making an object to be charged object is the motion of the electron. The motion of the electrons. So the electrons, when the electrons are leaving an object, that means that the number of protons is higher than the number of electrons. Therefore, the object becomes positively charged. And when the objects are going to another object, that means that for that second object, the number of electrons is higher than the number of protons, so which means that the second object is becoming negatively charged. This brings us into a second law that is known as the conservation of charges. Conservation of charges. It is more principle, and you'll have this principle in your data booklet. So what it is saying, like every conservation law, it is saying that the charges are conserved. They are not created or destroyed. They are moving from one object to the other. So whatever, if the two objects are in contact with each other, then whatever object one is losing is gained by object two, that they are in contact with each other. Now, the unit for charges is the unit for is coulombs, and it is with capital C. We see that we saw even on the previous on what we said before, we saw that that the charge of what is making an object to be charged is the motion of the electrons. So what do we have is that the charge is the charge of the electron is considered to be negative 1.60 times 10 to the power of negative 19 coulombs, and therefore the charge of the proton, which is the charge of the subparticles that are in the nucleus, is positive 1.60 times 10 to the power of negative 19 coulombs. And when we see 1 coulomb as a unit is roughly 6.25 times 10 to the power of 18 electrons, or this charge here. In other words, this number 1.60 times 10 to the power of negative 19 coulomb is known as the elementary charge. So what it's saying here that is that you cannot have a charge that is smaller than this elementary charge here. Okay, so now if and this makes sense because you cannot have a charge that is less than an electron that is moving from one object to the other. What do you have to come up with? The first part of the video is that electrons are the one that are creating the object or making the object to be charged. The charged object is as a result of the difference between number of electrons and a number of protons. Protons do not move. They are in one in the nucleus and they are stable. Do not move from one element, from one object to the other. And then the elementary charge is 1.60 times 10 to the power of negative 19 coulombs, and coulombs is the unit of charges. So now when we have a question in which we are asked what is the charge? So what is the charge? Charge is assigned with the letter Q. What is the charge of an object that has, let's suppose, 485 excess electrons? So now the charge is created, as we said, is created based on the motion of the electron. Since it has more electrons than proton, then the charge will be whatever is the number of electrons, so that in this case is 485 times the charge of the electron itself. So it is 1.60 times 10 to the power of negative 19 coulombs per one electron. So this is number of electrons, and this is coulombs per electron. So electrons and electrons will cancel out, and then the charge will be whatever is 4.485 times 1.60 times 10 to the power of negative 19, and this will be 7.76 times 10 to the power of negative 17 coulombs. And the charge, since we have excess electrons, is the object is negatively charged. In the case when we have absence of electrons and we are looking for the charge, then we have let's say 323 less electrons than protons. And then when we are looking for the type of the charge that the object has, so it's positive or negative, and the charge in coulombs will be again the number of electrons times the elementary charge. So will be 323 less electrons times 1.60 times 10 to the power of negative 19 coulombs per electron. So electrons and electrons are cancelled out, and then what we have is 323 times 1 point, and the charge is 5.17 times 10 to the power of negative 17 coulombs. And since we have less electrons than protons, then the object is positively charged. Okay, let's talk a bit about the distribution of charges in an object. If we have a sphere, a metallic sphere, something like this, where we are assuming that it has a certain volume, then the distribution of charges, if the object is negatively charged, will be something like this. In between, you may have some positive charges, like this. But as you see here, the number of the negative charges is greater than the number of the positive charges. So what do you notice here is that you have an evenly distributed charges along the surface, the outer surface of the sphere. But when you have an object that is, let's suppose, somehow pointed like this, then what do you notice is that this again is a negatively charged object, then you will have a more concentrated more concentrated charges here at the pointy part of the object and a less concentrated distribution of charges in the rounded part of the object. This is because what the charges have as a tendency is to just, escape, and they find the way to escape into the pointy surface. So this is again as a result of the shock that we have when we touch an object that is pointy, because the charges, the distribution of charges or the concentration of charges is more into the pointy object than into a rounded one or flat, or it's more concentrated here into the pointy part of the object that is charged. And again, you will see along those surfaces, you will see some positive charges here. However, the number of the negative charges is higher than the number of positive charges, so both objects are considered to be negatively charged. Even if we have an object that is positively charged, you will have the same configuration with more positives than negatives into the surface or in the outer surface of the object. And always when we have a flat or a round surface like the sphere, then the charges are evenly distributed. And when we have a pointy one at the pointed area or part of the object, then we will have a higher concentration of the object. Now we have two types of nature of the object when we have so objects may be conductor or isolators. When they are conductors, the charges can freely move. And when they are insulators, the flow of charges is very difficult. Therefore, we can say that since or if we have a conductor material like metals, ionic solutions, then the objects are easily charged. And if we have insulators, then it is very difficult to charge, if not impossible. So it doesn't allow the flow of electricity easily. And objects that are insulators are objects like wood, plastic, glass, and this is why we put wood to insulate to save ourselves from the charges of that are coming. Okay.